In this video, I'm going to explain to you how to obtain the derivative of an inverse trig function. Inverse trig functions are represented as, first of all, the function, so in this case it's sine, to the power of -1. So that will tell you that it's an inverse trig function. And it can also be represented with an arc. I mean by that, you would write arc sine of x. That is the same as writing sine to the -1 of x. So don't get too confused if you see the word arc before a function. It just means it's the inverse of it. So the way you differentiate an inverse trig function is the following. So the first thing you want to do is say that x is equal to the sine of y, which is going to be a conversion we'll use later. So I'll underline it with red. We then obtain the derivative of each side, which makes this side 1 because it's d of x over dx, and then it will be d of y over dx, so that will be cosine of y times dy dx, and this is what we want, the derivative of y, which is our function right here. So we make the equation equal to that, so the cosine would be dividing, dy dx would be equal to 1 over the cosine of y, which we can get back into sine if you know the identities. So the one we're going to use is the cosine of y squared plus the sine squared of y is equal to 1. And in this case we have the cosine, so we'll move the sine into the other part of the equation. Cosine squared of y is equal to 1 minus the sine squared of y. But we want to substitute these two, so we will have to make the cosine squared of y cosine of y, which means we will obtain the square root of each side. So the square root of cosine squared of y is equal to the square root of 1 minus sine squared of y. This becomes cosine of y is equal to the square root of 1 minus sine squared of y, and we can put that into our equation. I moved the text to have a little bit more space, so we put what we just obtained into the equation. We would have 1 over the square root of 1 minus sine squared of y. And now is when that conversion I was talking about becomes useful. So we have this part here and this here. So to simplify our derivative, we could put in the x into where the sine is written. We will get that 1 over the square root of 1 minus x squared is the final result, in which x, of course, is our function fx that goes right here, so which goes inside the arc sine. The same steps can be done with the inverse cosine, and I'll do that next. And like the previous time, we'll say that x, I'll change the color, I'll just write it in red, x is equal to the cosine of y. And like in the previous case, we will use that conversion at the end. The next step was to obtain the derivative of each side, which meant this would be 1 is equal to the negative sine of y times dy dx. we want dy dx, so dy dx is equal to negative 1 over the sine of y. And we want to make that into cosine, so we use the same identity, cosine squared of y plus sine squared of y is equal to 1. Pretty much get the same thing, that the sine of y, actually let me write this a little bit to the left, the sine of y is equal to the square root of 1 minus the cosine squared of y. We put this information here, so dy dx is equal to negative 1 over square root of 1 minus cosine squared of y. Now we make this change into here. We say that the final result is going to be negative 1 over the square root of 1 minus x squared. That's our result. Now there's 4 more trig functions that have inverses, and I won't be doing the procedure in every one of them because that will make the video too long. So I'll just give you the final result, but using the same steps, it should work. So here are all 6. I wanted to write them in their generic form, so we have u as our variable. We said that the formula for the inverse sine of u was y prime is equal to 1 over the square root of 1 minus u squared times du dx. When I was obtaining this, I did not write the du dx because it was the inverse sine of x, which meant that it would just be 1. But be aware that that exists there. For the case of the cosine of the inverse cosine of u, we would have that y prime is negative 1 over the square root of 1 minus u squared, again, times du dx. Now for the ones I didn't solve, first of all, the inverse tangent, y prime is equal to 1 over 1 plus u squared. So it's basically they're all similar, like in the way they're written, but some have a different sign, some have the square root. So be aware of that. The cotangent or inverse cotangent, sorry, is very similar to the inverse tangent. So I'll write that next. But instead it has a minus sign, so negative 1 over 1 plus u squared times du dx. I should really stick to one kind of 1. So it's always 1, just in case you don't get confused. For the case of the inverse secant, y prime is equal to 1 over the absolute value of u times the square root of u squared minus 1 times du dx. The inverse cosecant is the same with a negative sign. Absolute value of u times square root of u squared minus 1 times du dx. And well, as I did with the inverse sine and inverse cosine, you can obtain these formulas, but it would make your life easier if you memorize them. And well, the problem would be way shorter. Thank you for watching this video. I hope you liked it and found it useful. And well, if you did, Please be sure to give it a like and subscribe for more videos like this one.